Hello and welcome to this training. This is an introductory course in basic Windows and computing skills. Let's start off with some big picture items. The first thing is let's distinguish between two words. There's hardware and there's software. The hardware is all the physical components of the computer. If you can kick it, it's hardware. Next is software. The software is basically everything else that we talk about when we talk about computers. All software is based off of programming, so every program out there has some kind of language. Then you've got this thing called the operating system, and in this case it's Windows 7. And the operating system is software. It falls in the software category. And it has several jobs, but there are two main ones that I want to point out. First of all, the operating system is really the glue between the hardware and the software of the computer. And up here at the top, this is part of the operating system that you can see. And this is called the UI, or the user interface. It's the pretty part of the operating system, we can call it that. It's quite actually a small part of the operating system. The rest of the operating system, lots of going on here, but this is basically interacting with your computer parts in order to provide you the pretty picture. The other way to think of an operating system is to think of it as being like a stage. And on this stage is where you get to use all of your applications and apps. So think of those things as being dancers on the stage. So the operating system it's a platform on which you can run other software. There are megabytes, kilobytes, gigabytes, and all of those kinds of words, and it'll be really helpful for you if you kind of have a basic understanding of how big these bytes and megabytes are and how that actually impacts you on a day-to-day basis. So what you're looking at right now, this is 1 byte. And 1 byte has 8 bits. So each one of these is 1 bit. And a string of 8 bits is 1 byte, and this is enough information to contain the capital letter A. This is 1,000 bytes, also known as 1 kilobyte, which amounts to about a quarter of a page of text. Let's talk about megabytes. Back in the 90s, which is when I learned how to use computers, we had the floppy disk drive, and it had 1.44 megabytes of space. Now, so 1 megabyte is 1,000 kilobytes. 1 megabyte is 1 million bytes. When writable CDs became a thing, they became much more powerful, because one CD, like a music CD, could hold 737 megabytes. So, that's enough for maybe 14 or 15 songs on a musical album. It can hold many more songs if you're using MP3s. One MP3 song might be around 4 or 5 or 6 megabytes, depending on how good the audio quality is. Or a photograph taken by a digital camera might be 2 or 3 or 4 megabytes, depending on how the quality of the camera and the size of the photo. And then we could move up to DVDs. So this is a double-sided DVD disc and can hold about 7.8 gigabytes. So 1 gigabyte is 1 billion bytes, right? So it is 1,000 megabytes. So you could just keep on multiplying each of these by 1,000. It takes a lot longer to download 1 gigabyte than it does to download 1 megabyte. It can take several minutes to download a gigabyte, even if you have a fast internet connection. So a 7.8 gigabyte disk can hold, obviously 1 full-length film at a standard definition. Now, when we start talking about terabytes, when you buy a new computer nowadays, there is a chance that it might come with a 1 terabyte hard drive. Once again, just multiply by 1,000, so we're now talking about 1,000 gigabytes, or 1 trillion bytes. And then we can multiply by 1,000 again, and we have the petabyte. Petabyte is 1 quadrillion bytes. So a couple of petabytes is enough to hold all of the United States research libraries, or the film Avatar, which came out in 2009, all of its special effects fit in a little over 1 petabyte of storage. Normally, most of us would not reach this level of data need. Beyond petabyte, there are exabytes and zettabytes, but that is getting in the realm of the theoretical